Greetings to all. The session is regarding the entrance exams and competitive examination chemistry in specific to the intermediate level that will be fetching for your international floor and also India level JEE advanced, JEE mains examination for IIT and NIT admissions. A NEET exam will be conducted for medical entrance all across India. Telangana, Andhra Pradesh MCET examination for BTech entrance, and also competitive exams. If you are preparing there, the content is very much fetching. What are the chemical components of the human body? So this is the most important application based question regarding chemistry. What are the components regarding the chemical components present in the human body, and what are their proposition? What are their percentage composition we need to analyze? This is about your chemistry of your human body. Chemistry at humans, right? So the human body chemistry is going to be analyzed, where maximum quantity you can notice 62 percentage of water will be located, and the remaining 16 percentage of protein content is there. Very minute quantity minerals of 6% and fat is of 16% is present in the body. Carbohydrate content is 1 percentage, which is the responsible for energy. Water is the kind of medium where all the kind of metabolic activities get carried, and transportation device it will be that used to transport all the kind of produced products in the metabolic activities can be transformed from one place to another through water medium, and water acts as a solvent, and it is the platform where most of the human or living organism reactions takes place. Proteins are building blocks of the body for healthy growth and cell division. Proteins are very essential. How the nitrogen is essential to grow the plant material. In the same way, protein also contains nitrogen, which is required for the plant growth. Carbohydrate available in 1%, that is the energy device which used to give all the energy source for the activities of living organisms. And minerals also present in the 6% quantity. These mineral resources are essential to enhance, uplift the reactions whichever carried in the human body. Fat is the kind of layer which present excessive quantity of energy whichever produced can be stored in the form of fat. Fat is the kind of storage which is required whenever we are having lack of food, lack of energy. When that time fat will be consumed to give the additional energy to the human body. This is a kind of storage. How we save our money in the bank, in the same way energy in the human body can be saved in the form of fat, right? So that is a kind of storage. And if you go for the elemental analysis, this is about what component wise percentage to be analyzed. If you go for elemental analysis, individual elements, the maximum quantity element the entire human body is said to be oxygen, whose quantity is of 65 percentage. Oxygen is of 65% present in the human body, and carbon 18% composition of carbon will be there. Hydrogen is of 9.5 percentage. Next level element in the human body will be hydrogen, 9.5% will be there. Nitrogen is of 3.2%. Next level 3.2% nitrogen. Calcium 1.5% will be there. Our bones are made up of calcium phosphate, and phosphorus is of 1.2 percentage will be there. This nitrogen contributes for the protein synthesis. Hydrogen will be there in the form of water, in the form of protein, in the form of carbohydrate, in the form of minerals, in the form of fat. Everywhere you can find this hydrogen. Carbon is there in the form of protein, in the form of minerals, in the form of carbohydrates and fat. Everywhere you can find carbon. And the entire human body composed by carbon cells. Oxygen is the maximum quantity. You can find it in the water, you can find it in the protein, you can find it in the carbohydrate in the form of OH. Minerals also composed by oxygen, and fat also you can see oxygen. This is the way elemental composition. And potassium minute quantity. All these whichever mentioned this side are minute quantity. Potassium, if you go for 0.4%, infinitesimal quantity you can say. Sulfur is of 0.2% available in your human body. Sodium and potassium are said to be electrolytes which are required to maintain the blood pressure of human, right? Sodium is available in 0.2%. Its level to be perfectly balanced, then only blood pressure in the control, right? So chlorine is in the extremely minute quantity, 0.2%. Magnesium is of still less quantity, 0.1% will be there, and whichever elements traces are another elements also present, less than 1%. Okay, so this is about what entire human body and the composition of various elements and various components, chemical components, which are said to be biomolecules, whichever available in the human body are called biomolecules, right? So this is the way the question one can be answered, right? Where repetition of the topic, the highest extent of element whichever found is oxygen, highest molecule biomolecule found in the human body is the water. Then move on to question number two. Question number two is part of Cambridge Assessment International Education. When cobalt oxide, COO is called cobalt 2 oxide, is heated in the air oxide with the formula. Whenever oxygen is added to this cobalt monoxide, that is converted into CO taken thrice, CO taken for. This is a kind of polymer. We can achieve the polymer over here. CO3O4 can be formed. Balance the equation. This is one of the question related with the cobalt oxide to polymeric form. And when the oxide CO3O4 is heated with the hydrogen, cobalt metal will be extracted. This is a kind of metal extraction process by the reduction. Why can we say reduction? Because whenever hydrogen is added called reduction, oxygen removed also called reduction. In both the ways it is said to be a reduction process. Explain how this equation shows that cobalt 3 oxide is reduced. So we have to give the justification for this one, and both the questions to be answered. In order to answer this question, first of all, we have to go for stoichiometry. Stoichiometry stands for how can we get the balanced equation in both the sides. According to law of conservation of mass, left side components exactly is equal to right side components. Matter can't be destroyed, can't be neither be destroyed nor be generated. So that how many atoms or molecules are there, let's say those many atoms or molecules to be regenerated at right hand side. So if you observe, right side is completed one, left side to be filled with the blank. So in order to get the reactant side, first of all we have to observe the product side. In the product side, coefficient 2 is mentioned for cobalt 3O4. That means how many cobalt atoms you can notice, cobalt taken thrice will be there, and it is indicated with coefficient 2. So that let me multiply 3 with 2. So 6 cobalt atoms will be there. So 6 CO 6 cobalt oxide if taken, that combines with O2. Okay. So let me go for the counting of oxygens over here. The oxygen count in the right hand side are 2 multiplied with 4, it will give 8 oxygen atoms. Go with the left hand side, 6 times oxygens are there in the COO, and O2 is there, which is of 2 times. So 6 plus 2, it will be 8. Left side 8 oxygens, right side 8 oxygens, so that it is the balanced one. Only the requirement is 6 cobalt oxides combined with 1 mole of oxygen gas, so that 2 moles of CO taken, CO3 O4 can be generated. This is the polymeric compound whenever air is in contact with cobalt oxide. Okay. The second question to be answered, where cobalt oxide when treated with hydrogen, cobalt plus water will be formed. This is said to be a reduction, and we need to give the explanation exactly. So whenever hydrogen is added to any of the component is supposed to be reduced. That is one fundamental thing. In terms of oxygen, if any component is losing its oxygen atoms, so that it is converted into a metallic substance by losing oxygen. Loss of oxygen is called a reduction process. That is the second definition. We can explain even in the third definition as well. If you see this cobalt 3O4, if you observe, four oxygens contribute to -2 charge each, so that -8 charge will be there. -8 charge can be accompanied with the 3 cobalt atoms. So 2 plus 2 plus 2, if you go with the 6 will be 3 plus 3 plus 2, that will be 8. So 2 cobalt are there in the place 3, two cobalt is there in the +3, one cobalt is there in the +2. So in that condition, +3 and +2 now finally converted into cobalt 0. Any metal oxidation state is said to be 0 around the central metal. That is the fundamental, everybody know. So +2 and +3 is converted into 0, right? So that what happens? +2 to 0 means what, we are decreasing the oxidation number. Always any element or molecule or compound or the atom is decreasing its oxidation number, that is also called as a reduction. This is the way in different multiple dimensions you can explain. This is the process called reduction. Let me give in terms of hydrogen. Addition of hydrogen to any compound is said to be reduction. That is one way of a reduction. Second, any molecule, if it is losing oxygen, is called reduction. And third point, if any compound reducing its oxidation number is also called as reduction, right? In all these aspects, cobalt is supposed to be converted into metallic cobalt is the process of reduction due to loss of oxygen, due to loss of oxidation number, due to the addition of hydrogen. So this hydrogen is added with oxygen so that it is the process of oxidation. Hydrogen is supposed to be oxidized, cobalt is supposed to be reduced. So this is the way you can answer the question number 2. Move on to question number 3. Question number 3 is collected from 2017 paper 2 question paper of JE Advanced, right? Pure water freezes at 273 Kelvin and 1 bar pressure, right? Temperature and pressure is mentioned for freezing of water. Everybody aware 0 degree centigrade water freezes. So 0 degrees on the Kelvin scale, it is said to be 273 Kelvin. The addition of 34.5 grams of ethanol to 500 grams of water changes freezing point of solution. Generally pure water 273 Kelvin, but we are adding ethanol. So whenever ethanol is added, its freezing point got changed. Use the freezing point depression constant of the water as a 2 kilogram per mole. Okay, so K for depression constant, freezing point depression constant. K denotes freezing point depression constant. The figure shown below represent plots of vapor pressure versus temperature. Vapor pressure taken on the y coordinate, temperature taken on the x coordinate. Molecular weight of the ethanol is taken as ethanol molecular weight is also given for your convenience, that is 46 gram per mole. If this is the data provided, which is the correct representation of the graph for this depression in the freezing point? Okay, in order to identify this one, we have to go for what is the fundamental graph for the depression in the freezing point, and next what is the suitable formula in order to calculate depression in the freezing point. And this is the way we can go for the solving of problem. And for question number 3, expected answer is option number C. This is indicated with the tick mark. We have to see how can we get this answer. In order to remaining all may not be correct, because whenever temperature on Kelvin scale versus vapor pressure on bar scale is are taken, always curvature is obtained, and that curvature may not be represented like this. There is a provision to get the lines in this manner only for depression in the freezing point. Either B, C, there is a possibility. A and D blindly we can cancel out because this orientation may not be possible. Among these two, in order to get this clarity among these two, so here exact change in the value to be identified. If we calculate, so that you can put a tick mark over here. In order to get this answer, first we have to go for what is the formula for depression in the freezing point. This is the data collected from Liber text chemistry. Freezing point depression is the colligative property observed for the solutions. Introduction of any solute. Here the solute is ethanol for us. Of the solute to the solvent. The freezing point of the solution all lower, that a pure solvent is directly proportional to the molality. How extent freezing point is decreased, that is proportional to its molality of the adding substance. Depression in the freezing point is equal to Kf into M for molality. So that delta denotes what? Change in the freezing point. That is a change in the freezing point, nothing but freezing point temperature of the solvent minus freezing point temperature of the solution. Okay, it is exactly is equal to Kf into M. Kf is nothing but freezing point constant. This is the freezing point depression constant, M for molality, right? So delta Tf is nothing but is the freezing point depression value, and Tf solvent, Tf solution values are there. Okay, in order to use this equation, first specimen graph is provided where temperature and the vapor pressure are taken, are the reaction coordinates, so that always, just now we said that always the curvature should be inclined towards upward but not downward. So this is the specimen graph. You can notice always lines to be inclined towards upward. Upward lines only noticed in the option B and option C. A and D cancelled now. So among B and C, the exact graph to be depicted by calculating the values. In order to calculate, we just got the formula delta TF is equal to Kf into M. Delta TF is equal to Kf into M. Delta TF is the change in the depression in the freezing point. Kf is the freezing point vapor pressure constant. M is the molality. There is the formula for molality. Molality is equal to moles of solute per kilogram of solvent. It is the weight terminology. Solvent can be measured in kilograms instead of volume, right? So here molality mentioned with the small m. If capital M is there, that is called molarity. You have to find the difference. Molality is equal to moles per kg. That can be simply written as weight by gram molecular weight into 1000 by grams of solvent. Weight of ethanol added is 34.5 grams. Molecular weight of ethanol given in the problem itself 46. 1000 remains as the same numeral. How much water we are going to add? 500 grams of water you are going to add. Okay. So 34.5 by 46 into 1000 by 500, nothing but 2 only. So 34.5 by 46 into 2, you can directly write like this. The entire value will become 1.5. So that you got 1.5. Here Kf value, depression in the freezing point constant is provided. Depression in the freezing point constant is given as 2. So that 2 is indicated over here. This 2 means a Kf value. 34.5 is the weight of ethanol. 2 is nothing but 1000 by 500. 1000 is the numeral as such, and the grams of solvent water we have 500. That will become 2. 1000 by 500 is 2. Then 46 is the gram molecular weight of ethanol, which is given within the problem. So if you go with 2 into 1.5, that will be 3. So 3 is the change in freezing point value. So here one of the temperature is you already known. So one of the temperature you already known to you, that is 273 Kelvin. If one of the value is 273, so this delta TF value is 3. So 273 minus 3, the leftover value, change in the temperature is 270, right? So that will be 270 is one of the temperature and 273 is another temperature. At this 273, less than 270 Kelvin, you can notice the ice. At 273 you can notice the water. So this is the way calculation is carried. In order to calculate, the required formula is delta TF is equal to Kf into M. If you substitute the molality value and depression in the freezing point constant value, you can achieve this value. After getting this one, whatever initial temperature is there, we need to subtract the value so that depressed freezing point value you can achieve. Depressed freezing point value exactly mentioned in the option number C. So that the correct expected answer is option number C for question number 3. Move on to question number 4. Question number 4 is also collected from 2017. JEE Advanced paper 2 question paper. For the following cells, zinc, zinc sulfate, copper will be taken. And this is the cell notation. Simply, it is a galvanic cell, we can say. When the concentration of Zn plus 2 is 10 times the concentration of copper plus 2, that indicates what zinc sulfate is more concentrated in comparison to copper sulfate, 10 times more concentrated. The expression of delta G is delta G, change in the Gibbs free energy to be calculated. For that, Faraday value, Faraday is the constant known to everyone, that is 96,500 coulombs. R is the gas constant value, T is the temperature value. Being all these the parameters are the part of Nernst equation, it is required to be mentioned like this. Delta E naught for the cell. Zinc copper is the common galvanic cell whose standard electrode potential is calculated as 1.1 volts. The expected answer for this delta G value to be calculated as 2.303 RT minus 2.2 F. This is a required answer. In order to get this one, we have to go for the calculation. First of all, we have to see the Nernst equation, and half cell reactions are mentioned. Zinc is the anodic metal, always lose the electrons, giving Zn plus 2. Copper plus 2 is a cathodic metal where acceptance of 2 electrons got carried. Metallic copper will be generated. Loss of electrons, gain of electrons get compensated. And zinc, upon combination with the copper plus 2, formation of Zn plus 2 and copper metal is possible. This is the net cell reaction we will achieve. Applying the Nernst equation, E cell is equal to standard electrode potential of the cell minus 2.303 RT by NF log of product concentration by reactant concentration. Right, product concentration, here products we have Zn plus 2 and copper, reactants we have zinc and copper plus 2, but always only Zn plus 2 and copper plus 2 are taken as reactant and product, but not copper metal and zinc metal. Why? Because any metal added to water, will it show any concentration? For example, let me take the coin of gold. Gold coin added to water, will it dissolve in water? No metal is water soluble. When it is in ionic form, then only it will impart the concentration. That's why always metal concentration is taken as 1 unit. So that product side you can indicate Zn plus 2, reactant side you can indicate copper plus 2. So Zn plus 2 by copper plus 2 is indicated over here, and standard electrode potential is taken as 1.1, which is given within the data. 2.303 numeral remains as such. R is the gas constant, T is the temperature, N is the valency, how many electrons transferred in the reaction. 2 electrons are supposed to be transferred. N value is 2. F is the Faraday, whose value is constant always, that is 96,500 coulombs. So that they already said that Zn plus 2 concentration is 10 times higher than copper plus 2. For example, copper plus 2 concentration is 1 mole, then Zn plus 2 concentration will be 10 moles. So this is the way 10 times you need to rise. So 10 by 1 is nothing but log 10 only. You can simply write it as a log 10. Okay. So after mentioning like this, 1.1 minus 2.303 RT by 2F log 10 value is always 1. So need not to mention 1, because any parameter multiplied with 1, that remains as such. So that log 10 is 1 only. So this is for what? E cell. Electrode potential of the given zinc copper galvanic cell is calculated. Now the question is regarding the change in Gibbs free energy. Gibbs free energy is equal to minus NF E cell. N for valency, F for Faraday, E for E cell electrode potential. So here N already known, 2 electrons got transferred, in values 2, and F is also known to you. If N and F is known, E cell value, just E cell, just now we calculated through Nernst equation, as such you can put over here. Whenever minus 2F, 1.1 minus 2.303 RT by 2F can be taken, then after the entire calculation, the value will be concised to 2.303 RT minus 2.2 F. minus 2.2, F will be obtained. So this is the way we can achieve, and which is perfectly mentioned in the option number B, so that you can cancel out all the remaining options whichever present. So for question number 4, option number B is the correct answer. Move on to question number 5. An alkyl halide X upon reaction with sodium metal in the dry ether gives a 2,5 dimethylhexane. What is X? In order to go for the searching of answer, searching of entire reaction, first of all, we have to identify what reaction it is. ఒక ఆల్కైల్ హ్యాలైడ్ ఎక్స్ అనేది పొడి ఈథర్ సమక్షంలో సోడియం లోహంతో చర్యనుంది 2,5 డైమిథైల్ హెక్సేన్ ఇస్తుంది. ఎక్స్ అనేది ఏంటి ఇక్కడ? సో this is the kind of reaction if you are going to calculate. First of all, we have to know this is called what's the reaction? What's the reaction where you can use alkyl halide that can be treated with metallic sodium under dry ether conditions. They get remove sodium halide so that higher alkanes will be synthesized. This is the entire process regarded as the Woods synthesis. In order to go for the synthesis, we have to take the starting material isobutyl bromide, being the product is 2,5 dimethylhexane. In order to achieve this one, the starting material might be isobutyl bromide. Let's see how can we go with this. What's the reaction? Any alkyl halide upon reaction with metallic sodium under dry ether solvent conditions, this halide will be condensed with sodium. Two alkyl get attached directly and gives rise to higher alkanes. This is the reaction called Woods reaction. The isobutyl bromide, if taken, because product is known to you, you can go with the retrosynthesis. First of all, we have to write this product. What is the product? 2,5 dimethyl cyclohexane. If you want to get this product, here is the combining factor, here is the new bond formation. In order to form the new bond over here, this is the one with the 4 carbons, this is the one with 4 carbons. 4 carbons containing halide can be taken, and this side also 4 carbons containing alkyl halide. 2 moles of alkyl halide upon reaction with sodium metal, you can remove 2 moles of sodium bromide. So here we have to put 2 coefficient. So NaBr can be removed. That gives rise to a 2,5 dimethylhexane. So it is a simple reaction. You can solve this problem by retrosynthesis. Product to reactant side, you can move in a backward direction. This is the way we can answer. For question number 5, option number 2 is the correct answer. Move on to last question of the session. Which of the following statement is not correct about the X and Y from the given reaction? This is the kind of carbon-carbon triple bond where butane, 2 butane will be there. Sodium in liquid ammonia, hydrogen, palladium, carbon. Sodium in liquid ammonia is called what? Birch reduction, and palladium carbon hydrogen is called Lindelard's catalyst. Palladium barium sulfate used, or else palladium carbon is also used. Sodium in liquid ammonia is the reagent for trans addition, and trans alkene will be generated. Palladium carbon gives rise to the cis alkene. Cis 2-butene is the product at Y. Trans 2-butene is the product at X. The question is, which of the following is not correct about X and Y from the given? క్రింది చర్యల నుండి ఎక్స్ కామా వైలకు సంబంధించిన వ్యాఖ్యలలో ఏది సరైనది కాదు? ఎక్స్ అనేది సిస్, వై అనేది ట్రాన్స్. ఎక్స్ ఈస్ ద they are saying X is cis, but X is a trans, Y is cis. Always Birch reduction gives rise to the trans alkene, and Lindelard's catalyst gives rise to the cis addition. They mentioned with the wrong one, so the first option only, odd man out. You can put a tick mark over here. And the next is about X and Y are geometrical isomers. Cis trans are also designated as a geometrical isomerism. If 2 similar groups are on the same side, called cis. If 2 similar groups are on opposite side, called trans. Both are the part of geometrical isomerism, right? X మరియు Y లు క్షేత్ర సాదృశ్యాలు. Geometrical means క్షేత్ర సాదృశ్యాలు. Correct only. This is a correct only. Dipole moment of X is less than Y. Always a trans isomer dipole moment is taken as 0, because in both the directions their the values got compatiated, they get cancelled out. So the trans butene having dipole moment 0, whereas this is having larger extent. So whatever they mentioned here, dipole moment x is less than y, that is correct only. X is 0, y is somewhat larger magnitude. X యొక్క ద్విధ్రువ భ్రామకము y కంటే తక్కువ, ఇది కరెక్టే. Y is less stable than x. So y is less stable than x. So always a cis isomer, if cis isomer is having two bulky groups are on the same side, there is a kind of a steric repulsion among, because they are occupying, bulky groups are occupying the same plane, same spatial arrangement they are occupied with, so that they can find steric hindrance. So that always cis isomer having hindrance over trans isomer, but only the correct representation, the first option is the correct one. So first option is wrong statement to be identified, that is first one only. Let's see in detail. Sodium in the liquid ammonia, Birch reduction got carried. Always Birch reduction gives rise to trans to butene. So why it is called a trans to methyl? Similar groups are inclined in the opposite direction like this. One methyl upside to a second methyl downside, which is called a trans to butene. Whenever 2-butene is treated with palladium carbon, that gives rise to the two bulky groups are on the same side. Both are inclined in the same direction, that is called a cis isomer. Always Lindlar's catalyst gives the cis isomer, Birch reduction gives rise to the trans isomer. This is a fundamental known to everyone. And move on to the dipole moment. So whenever trans isomer taken, whatever dipole moment shown by this direction, perfectly balanced with this direction, so that it is 100% 0. Dipole moment taken as 0 for this. But in case of cis isomer, both are in the same inclination, both are in the same direction. That's why dipole moment is larger. So here dipole moment for the trans isomer is 0, whereas cis isomer is higher. If cis and trans isomer are taken into the consideration, highly stable one is the trans in comparison to cis, because whenever cis isomerism is there, both the bulky groups are inclined in the same direction. They are not in the sufficient dimensions. Trans isomer, they are far apart, and which are in the convenient spaces, so that this is a more stable one, right? So entire data, whatever mentioned is correct, except option number 1. For question number 6, option number 1 is the correct answer. This is the way we can go for the completion of the session. Entire questions got answered. All are most relevant for the examination. Definitely we can expect the questions from our JEE Advanced, JEE Mains, NEET Chemistry, or else MCET examination. This kind of examination pattern will be there, and this is the way questions will be given, and this is the analogy we can go to solve if the questions are given, so that the session is really informative for your examinations. And we covered with the various dimensions of chemistry, problematic session, explanation part, chemical reaction mechanism, entire dimensions of the chemistry got covered over. And I'm sincere to request to like the channel. In order to comment, we have a question over here. From the session, the required question to be answered is, if the geometrical isomerism is taken into the consideration, in case of geometrical isomerism, what is the difference between cis-trans and EZ nomenclature? Cis-trans part of geometrical, EZ is also the part of geometrical. What difference you can notice, that to be commented in the comment box. And you can share this content with the aspirants who are seriously preparing about the examination. Subscribe the channel to achieve more updates in the near future. And thank you very much for your patient listening. Thank you one and all.